Hello everyone, welcome to my channel Indian School of Physics. So guys, today this is a lecture series, short lecture series with some key concepts and key concepts applications I'll be discussing here. And this is the first one, and which is laws of motion tutorial 1. And here we are going to see the advantage of frame of reference, and you can see uh, how much advantage these frames of reference will give you in solving a problem. All right, so here I'm choosing a problem from Pathfinder, and this is one problem where traditional kinematics approach, if you use, you will be getting the answer. But if you choose the right frame of reference, this question becomes a very beautiful problem, and this is what we are going to discuss here. So particle on a rod. So we have to calculate this tension as a function of theta, and it is given that this particle is sliding on this fixed rod, and this end, which is connected with a inextensible string, and the other end of the string, point P, is pulled with a constant velocity. Please remember this constant velocity term. So the very first thing which we will get here is, here when this angle is some theta or theta naught, let's say tension in the string is T, and it is traveling at that moment with the velocity of v1. So now here with this tension component, you can see normal reaction will be acting on this bead as well. So the very first thing which we will do is we can balance the tension and normal reaction. So we are getting T sine theta naught equal to n. So T sine theta equal to n. And another thing we can write is string constraint. So if this velocity is v naught, so along the length of the string, all points will have same velocity. So v1 cos theta naught is going to be v naught. So these are the two fundamental equation I think everyone knows and will be writing in this problem. But the another thing is, since it is moving with constant velocity, here the advantage is we don't have to worry about pseudo force, because it will be a frame which is non-inertial, which is inertial frame. Here there is no need of pseudo force, and since length of the string cannot change, so the advantage is, with respect to this point, this particle will be moving in a circular path, and this is where this question becomes very interesting. Otherwise we are going to differentiate this relation in order to find tension, and then we will be writing rate of change of this angle theta. That is another approach of it. But here this will make it really beautiful problem. So with respect to point P, particle will move in a circle. So I am going to observe this particle, this bead, with respect to particle P. So if this point will come to rest, this length is L. Now here tension T is acting, and another real force which is acting here is N. And since path has to be a circular path, then I can say the relative velocity along this line has to be 0. So whatever v naught it was having, you are giving it to this, and v1 cos theta naught will balance it. So the only velocity which this particle will have with respect to this, it is v1 sine theta at this particular instant. So let's write net force towards the center. That means center of circular path, that is towards point P. So here tension is having one component. So tension T minus n cos theta naught, n sine theta naught is equal to mv sine theta whole square by L. I hope guys you are able to understand this, how I am writing this. There is this tension T, and this component of normal I am taking along the radial line or towards the center of the circular path, and that is equal to m into v relative whole square. Here the component of v relative will be along the circle, because with respect to path point P, path is going to be a circle. So we are getting another equation, which is T minus n sine theta naught is equal to m times this velocity is v1 sine theta naught whole square. Now here we can substitute the value of n, and we can substitute the value of v naught also. V1, I'm going to use this relation, and I'm going to use this relation. So you can see here this will become n value. If I substitute, this will become it was t sine theta, so this will become t minus t sine square theta naught, and here mv1 square sine square theta naught. Just substitute the values, so you'll be getting 1 minus cos square theta naught, it will come here. So tension T is coming as mv1 square by L tan square theta naught. So now we can substitute the value. So tension T we are getting as mv naught square tan square theta naught divided by L cos square theta naught. This is going to be the answer for that Pathfinder problem. And once we know this tension T, it's very easy for us to calculate acceleration, and which is t cos theta naught by m. So just substitute the value, and we are getting this part as v naught tan square theta naught by L cos theta naught. I hope you are getting this idea how question became very easy for us when we changed the frame, and compared to the traditional kinematic approach for this problem. So I hope you have enjoyed this video. So if that is the case, please leave a like, share this video with others, and if you haven't subscribed to my channel, please subscribe it. I'll be coming up with another video very soon. Thank you. This is about Compete, and as you know, it's a very unique feature of an academy platform where you can uh, play, you can battle. I'll call it battle instead of playing. So both of the parties will be getting a certain numbers of problems from PCM, and based on the winner, you'll be getting some rating points. So it's a very fantastic way of learning, I'll say. And there's another one about those who are participating for a state CET. So there is some discount going on. You can use it, or if you want to connect with me on an academy live classes, you can use my code Nitin sir. So that's it guys in this video, and do check it out. The next problem, it will be a challenging one, and I'm sure many of you